Hmm. Today we go for DFT problems. Now the DFT problems that we have to understand. Okay. Now here first problem is obtain n point DFT of impulse signal del of n. Now here how you can solve this problem? So for this point of view here we consider x of n. X of n is discrete time signal. Now this discrete time signal x of n is nothing but del of n. This is the impulse signal. Okay. Now here this is our input. Now according to definition of discrete Fourier transform. What is discrete Fourier transform definition will say that says x of n, x of k is equal to summation of n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi n k by n. Okay, this is a definition. Now, as per this definition, we are solving our problem. Now, we know the impulse signal. We already studied the standard input signal. So that's why standard input signal what says del of n is equal to 1 when n is equal to 0 and it is 0 when n is in another cases. Okay, when n is not equal to 0. Means by graph, we will draw it as a here del of n will be present. Here a origin point is there. Here n signal is there. And here del of n has unity. So that's why del of n will be 1 at n is equal to 0. And in other cases, it will be 0. Okay. So this is our definition. Now, as per the definition, we are proving the problem. Okay, here we have to prove obtain the input DFT of impulse signal del of n. Okay, now here we say del of n is equal to 1. Okay, only when it is 0. So we put it in our definition. Put del of n in definition. Okay, so here x of k is equal to summation of n is equal to 0 to n minus 1 into del of n e raised to minus j 2 pi n k by n. Now here, what the definition will say? What the definition will say? N is equal to 0, then it will be 1. So that's why this del of n will be unity and this n will be 0. So that's why if this n will be 0, that e raised to 0 will be there and e raised to 0 will be 1. So that's why it is 1 into 1. Okay, and you will get x of k is equal to 1. Okay, so that's why here you can prove here del of n is directly proportional to unity if you find its DFT. Okay, so the DFT of del of n is 1. Okay, this will be proved from this expression. Okay, now this is the first problem. Okay.